There we go.
And I think I already started the live thing.
Oh,
Yep,
yeah.
I did. Okay. All right. Let me find the group quiz again. I felt like this was a lot of what we've already done, except like with all new terminology.
Kinda, yeah.
That's kind of how I felt. But it's okay. Oh, notice my kid's artwork. So, anyway, okay, so you just want to start like the group quiz?
Yes.
Unless there's anything you want to talk about first. Okay, do you have the group quiz up?
Yeah.
All right, so which hypothesis involves equality?
I was down too far. I was like, what? That's not the right one. The null hypothesis.
Okay, because that's like the one you have to disprove, right? The one that you assume is true.
Yeah.
Unless.
So they always equal each other.
Okay. Okay.
So the p-value, information for the next question. The p-value is the probability of obtaining a sample statistic at least as extreme as the one that was actually observed. Remember that the p-value, which is basically what I just said. So when computing the p-value, which hypothesis do you assume to be true? Which we just said.
Null hypothesis.
Yep.
Okay. All right. Number 5, right? Okay. Suppose the null hypothesis is that equals 10. Okay. Which of the following represents the alternative hypothesis for a two-tailed test? So two-tailed is the not equal to, right?
Correct.
Okay.
So that would be the third option down.
Yes. Which of the following represents alternative hypothesis for left-tailed test? That's less than?
Yep, the first one.
And then right-tailed is greater than, which is the second option, right?
Yep.
Okay.
So remember that we determined the outcome of a hypothesis test by comparing the p-value to the level of significance, or A. What relationship would result in failing to reject the null hypothesis?
Failing to reject.
So that's greater than, right? P-value greater than.
If the p-value is, wait, I'm looking at my notes. If the p-value is small, wait, that's not the right notes. Well, like it says it, but it's not. Yeah, so since if the p-value is greater than A, you reject it. Right? Is that what you just said?
Yes.
Okay.
Well, so I think, so it's the first option though, right, on our thing?
Right, yeah.
If p-value is greater than A.
Yes, if the p-value is greater than A, yeah. To reject the...
Wait, do you reject? Because this says you fail to reject.
Fail to reject. I'm trying to read my notes here. Fail to reject the null hypothesis.
Yeah, that's what I was thinking.
Which relationship would result in failing to reject the null hypothesis is not the first option, right?
Yeah, greater than.
Okay, we're good. All right. So which relationship would result in rejecting the null hypothesis?
I believe it's less than A.
What's the difference between those two questions? Result in failing to reject and then rejecting. See, that's what I was like. The terminology, failing to reject and then reject, like they both use the word reject. So in my mind, it's both rejecting. Okay, I got it. I just have to get used to it. That's all. Like once I get used to it, I'll be fine. But man, like, okay, so if it's less than A, you reject it.
Yes.
When the p-value is small, right?
Mm-hmm.
Or less than A. Okay. All right. Whew. Okay, an insurance company is reviewing its current policy rates when originally setting the rates. They believed that the average claim amount was $1,500. They are concerned that the true mean is actually higher than this. Which of the following would be appropriate alternative hypothesis? So if they think it's higher, that would be greater. The average claim amount is greater than?
Yep.
Okay. That's the third one, right?
Mm-hmm.
Okay. Which of the following would be appropriate? Null hypothesis. The average claim is equal to?
Yep. Because null hypothesis means equality.
Okay. And then
I didn't read the next ones.
Okay.
The insurance company randomly selects 40 claims and calculates a sample mean of 1650. The insurance company assumes the distribution of the sample mean is normal. Is this a good assumption?
Yes.
Yes, because we have a large sample size.
Okay. Which is the first one, right?
Yep. And then what law or theorem justifies our previous answer?
Central limit theorem?
Central limit, yep. If the sample's big enough, then you should have a normal distribution.
Okay. Which of the following is the test statistic as defined in this lesson?
Z.
Z? Oh, yeah. I actually remember that from the video. Because it's just the Z-score, right?
Mm-hmm.
Okay.
So the historical mean of sales receipts at a grocery store is $150 with a standard deviation of $40. The store manager suspects that the average has decreased. She sets up a hypothesis test with these hypotheses. She'll use a level of significance of 0.05. She then takes a simple random sample of 36 sales receipts from her store and computes that X is $144. What is the Z-score associated with this test?
Okay.
Gotta flip my page forward.
So we do 144 minus 150, right?
Uh-huh. Over 40 divided by square root of 36. -6 over that number repeating.
Okay, did you get negative 0.899955?
Got 0.9, negative 0.9.
Yeah, that's good. Where's the quiz? I have so many of these things.
So the next one is the p-value for the p-value associated with the z-score from the previous question.
If it says round to 3 decimals, number 15.
When I did it, I only got 0.9.
Oh, I got 0.89995500.
Probably because I used what did you use for your bottom number?
6.667.
Yeah, so on my calculator, I did last answer, which means it takes into consideration a lot more of those decimals. So mine ended up just being nicely at negative 0.9.
That is nice.
So, yeah, that's why it's a little different.
So what should we put for the answer? Because it says round to 3 decimals or just
negative 0.9.
Or yeah, negative. Sorry. So just put negative 0.9.
Mm-hmm.
And just don't worry about the 3 decimal places.
Yeah.
Okay.
I worked it out earlier, so
I can handle that. Okay, sorry, keep going.
So p-value. What is the p-value associated with this z-score? So we use the applet for that.
Oh, right. Okay.
And put in our z-score that we just found. So 0.9.
And
it's only the left shaded, the far left, right? Well, I guess it doesn't matter. It could be either side, but this is negative, so just kidding.
Less than, right?
Yeah, it's far left because we have a negative z-score.
Okay, so that's 0.1841. Is that what you got?
Yep.
So round to 3.
184.
Okay.
What inference can we make about the null hypothesis for this problem?
So are we assuming that the A is, or is that the one that we compare to? A is 0.05 or something like that?
It's 0.05.
Yeah, 0.05.
So we failed to reject the null hypothesis.
Okay. Because this is bigger, right?
Right.
Because 0.8 or 0.9 is larger than 0.05. Is that right?
Yes. Well,
I guess this is negative. Oh no, because it's 0.18 that we're comparing. Is that what we're comparing?
I was going to say, I think we're comparing it to the p-value, not to the z-score.
We are. Yes.
So yeah, it's
p-value. I'm just going to write that down so I remember it.
Yeah.
P-value is larger than, or it's just.
Yeah, okay. So it failed to reject.
That fail to reject. Okay, I just had to make a note. Okay.
Yeah, and let me make a little note for myself as well. Okay.
All right. What is your conclusion for this problem? Insufficient evidence that the true population mean is 150. Sufficient evidence that the true population mean is 150. Sufficient evidence that the true population mean is less than insufficient evidence. Sorry. That the mean is less than 150, or sufficient evidence that the true population mean is less than 150. So is this insufficient evidence that the true mean is less than 150?
Yes.
Okay. I think I'm understanding this.
Good job.
All right. There are two types of errors that can be made when performing a hypothesis test. Which one involves rejecting the null hypothesis when the null hypothesis is true?
Type 1.
I'm like, I have to look up that one because I'm like, yeah. Not when. Yes. Okay. I got to figure out a way to remember that, like the difference between those two.
Yeah.
Like, I got to connect something somehow. Yes.
Alrighty, a researcher decided that instead of using a level of significance of 0.05, he will use 0.01. Which of the following will be true? The probability of a type 1 error will increase. The probability of a type 2 error will increase. The probability that the null hypothesis is true will decrease. Or his experiment will be more scientifically valid. So type 2 error.
I'm like, it's one of the errors.
I think it's type 2.
I think it is too, but I only am thinking that because I am remembering something from the video. I don't really know why. I guess because that would make it more possible to something. I'm trying to like make the connection in my brain. So if the A level of significance is smaller, you have a greater chance of failing to reject. Is that what where this is coming from?
Sorry, I'm looking at our reading real quick.
I'm ready. Gonna catch my toy.
You're still awake?
Mommy, I have to go catch my toy.
Okay, and then go lay down and fall asleep.
After my game with Archie.
Okay. Bye.
Bye.
Yeah, so type 2 is failed to reject.
Okay. I think I get it. Because if the level was less, even more things you would fail to reject. Right. So you'd conclude that it. I keep going back to that flip-flop example. So you would conclude more things were flip-flops when they actually weren't. So that would be a type 2 error. Right? I don't know if that made sense to you, but that flip-flop example really is sticking in there.
In the reading, it says if, okay. So it says we don't want to commit type 1 errors, so why not choose a small value for A? If we choose A to be so small that we rarely commit a type 1 error, what would happen to the probability of committing a type 2? So it says that if our A value is very small, the probability of committing a type 2 error will be large. So moving from 0.05 to 0.01 increases the likelihood of committing a type 2 error.
Okay. All right. Okay, last one. If A equals 0.05, compute the probability of committing a type 1 error.
It's 0.05. I just read that in the text.
I'm like, how do you compute that? Or is that just like a rule you should remember?
It just said that the most common value for A is 0.05.
Okay.
So that's usually what it goes with.
So the probability of committing a type 1 error is just 0.05.
Says that 0.05 seems to strike a good balance between the probabilities of committing a type 1 versus a type 2 error.
Okay.
So it's not the only one, but it's the best one, I guess.
Okay. All right, that's all of them. Submitting.
Did we get them all right?
Yes.
Yeah.
Did. Awesome. That was my text telling me that we got 100%. Okay, I'm going to stop the broadcast.